So before going further, we need to be clear on some notation. In the first chapter, I made a big deal about the distinction between a population and a sample. This is important enough that we actually have different symbols for the mean and standard deviation for each group. Now, when we're talking about a sample, we'll represent the mean with an X with a bar over it, and the standard deviation with the letter S. On the other hand, when we're talking about the population, we're going to use two Greek letters. The Greek letter mu represents the mean, and the Greek letter sigma, that's a lowercase sigma, is going to represent the population standard deviation. So what I want to do now is give kind of a visual or a geometric feel for what the standard deviation means. So I've got a histogram here representing one of our usual topics. It's a set of test scores. And I've calculated its mean and standard deviation right over here on the left. And I've graphed the mean on the chart, right? That's this X here. It's about 0.73. Okay, now suppose I calculate one standard deviation up from the mean. That's X bar plus S. That's 0.7375 plus 0.154. Right, that is let's see, that's 0.8915. And then I'll go the other way, right? I'll calculate one standard deviation down from the mean. That's X bar minus S. That's 0.7375 minus 0.154, which is 0.538. And you can see those values, right, on the graph here. Clean up my notes. There we go. Okay, so what this is saying is that all of the values between these two bars are within one standard deviation of the mean. Now, I can do this again. Right, I can do this again with two standard deviations. Going two standard deviations up and two standard deviations down. And if I do the calculations there, I get 1.0455 and 0.429. Putting those on the graph shows all of the values that are within two standard deviations of the mean. So this idea of locating how many standard deviations a value is from the mean is going to be an important consideration when we're doing a lot of calculations going forward. And we'll talk more about this a couple of lectures further along when we talk about something called the z-score. So what I've done here, right, is I've just simplified the drawing. I've narrowed it down to two standard deviations above and below the mean. Now what I want you to notice here is that almost all of the data is within this 4 standard deviation range, right? This is going to happen commonly enough that we can use it to come up with a way to approximate the standard deviation of a population, right? This is a useful technique since the standard deviation of the population is something that we're going to need to know for a number of future calculations, but it's something that's also going to be very difficult to calculate exactly. Okay, so here's how it works. If approximately all of the data lies between these two values, then these two values are approximately, say approximately, the maximum and minimum values. Okay, but remember, the maximum value minus the minimum value gives me the range. Right, so the range is the maximum value minus the minimum value, which is approximately x bar plus 2s minus x bar minus 2s. So if I simplify this, right, this is x bar plus 2s minus x bar plus 2s, and those x bars, those means, they cancel each other. So this is approximately 4 times the standard deviation. Now, if we divide both sides by 4, we get a practical approximation for the standard deviation. S is approximately the range divided by 4. Right? And this approximation has a name. This is what we call the range rule of thumb. So we're going to use this to just kind of file it away. It's going to be a little while before we circle back to this. But eventually we're going to use this in situations where we need to know the population standard deviation, but all I have is the maximum and minimum value from a sample. All right, so let's see how this works. Right, this is the data set that we used in the last lecture when we manually calculated the standard deviation. And you remember the end result came out to the square root of 8, which is about 2.8. So now let's use our range rule of thumb and see how the results compare. Right, well, the maximum value here is 9, and the minimum value is 1. So the range is 9 minus 1, that's 8. And our range rule of thumb says the standard deviation is approximately the range, that's 8, divided by 4, that's 2. Okay, well, and that's pretty close, right? 2 and 2.8, 8/10 off. It's not too bad, right? Turns out to be a pretty accurate approximation for our example here. So in the next lecture, we're gonna go back to our 5 attributes of data, and we're gonna look at methods for thinking about how data is distributed. We're really gonna drill down to the individual data value level and talk about ways that we can locate the position of a data value within the larger data set.